Let's talk about a classic heist movie. Before anyone even thinks about cracking a safe, what's the first thing the crew does? They case the joint, right? They watch every entrance, every camera, every guard patrol. Well, it turns out that's exactly how a cyber attack begins. So today, we're going to learn how to case the digital joint using a process called active reconnaissance.
So really, how does it all kick off? We always see the big, dramatic headlines about data breaches, but what's that very first step an attacker, or for that matter, a defender actually takes?
It's not some big, loud explosion. It starts quietly. It starts with a whisper. This whole initial intelligence gathering phase is called reconnaissance. It's all about building a map of your target, figuring out its shape, and finding any interesting spots before you make a single loud move.
Now, reconnaissance basically comes in two flavors. You've got passive recon, which is like digging up public blueprints or reading news articles about our target. It's totally safe, super quiet, and nobody even knows you're looking. But then there's active reconnaissance, and that's what we're digging into today. This is like walking right up to the building in the middle of the night and literally trying every single doorknob. Yeah, it's way riskier, but the info you get is gold. It's direct, it's accurate, it's real-time.
All right, so our digital heist is officially on. Phase 1 is all about finding the potential ways in. And in the world of networks, that means finding which computers are online and which doors they've left open to the world.
Let's really stick with our building analogy here because it works perfectly. A company's entire network, that's the building. And the ports? Well, those are all the doors, all the windows, the mail slots, you name it. An open port is just a door that's potentially unlocked, a way to talk to whatever service is running inside. So our first job is to just walk the perimeter and see which of these are actually open for business. And when we check these doors, we get one of three answers. Open is simple. A service is listening. The door is unlocked. Closed means, yep, the host is real, but nothing's listening on that port. The door's locked. But filtered? Now that's the interesting one. That's like finding a brick wall built right in front of the door. A firewall is blocking us, so we can't even tell if the door behind it is locked or unlocked. And hey, even that is super valuable information. So how do we actually jiggle the doorknobs? We don't just knock. Scanners send these very specific, specially crafted TCP packets to the target. And it's the target's response, or sometimes the complete lack of a response, that tells the whole story. The way it answers back tells us everything. And this is where it gets really cool, because it's all about how you choose to check that lock. A TCP connect scan, that's the loud and proud method. You fully connect, it's like throwing the door open and yelling, "Hello!" It works, but it's super easy to log. Then there's the TCP SYN stealth scan. It's much quieter. It's a half-open scan. You start to knock, but you pull your hand back right before it connects. This usually avoids application logs, but a good firewall will still spot you. And then you have the really sneaky stuff, like FIN or XMS scans. These send totally weird, malformed packets to trick the target into revealing its state. It's a whole different level of sneaky. Okay, to do any of this properly, you need the right gear. A professional doesn't just show up with a hammer. They have a specialized toolkit, and when it comes to active recon, there are two tools that are legendary. First up, you've got Nmap, the network mapper. Seriously, this thing is the Swiss Army knife of networking. It's precise, it's versatile, it goes incredibly deep. You use Nmap when you want to create a perfect, high-resolution blueprint of one single building. Every door, every window, what it's made of, and who might be inside. And then you have Masscan. This is not a Swiss Army knife. This is a sledgehammer. It's a tool built for one thing and one thing only: absurd, mind-bending speed. You don't use Masscan to inspect one building. You use it to check for one single unlocked door on every single building in the entire city, all at the same time.
And when I say fast, I don't think you're really getting it. Masscan can fire off 10 million packets per second from one computer. To put that in perspective, at that rate, you could scan the entire internet for a single open port in under 5 minutes. The scale is just staggering.
So let's put them side by side, because this really nails the difference. Nmap is for deep, detailed, methodical work. It uses your computer's built-in networking system, which is reliable but slower. Masscan is all about pure horizontal speed. To get that fast, it actually bypasses your operating system entirely and uses its own custom networking stack. The trade-off? It can't do the deep analysis like Nmap. It finds open doors at a massive scale, and that's its whole job.
Okay, let's keep going. We found an open door. Now what? Well, what can we figure out just by listening at it? This is where we move from just finding doors to actually identifying what's on the other side.
Right, so an open port is just an opening. The real intelligence, the stuff that matters, comes from figuring out what kind of room is on the other side. Is it a web server, a database? What specific software is running in there?
You know, funny enough, a lot of the time, the service will just tell you. This is called banner grabbing. We can use a super simple tool to connect to an open port, like port 22 here for SSH, and just listen. The service often sends back a banner, which is basically a welcome message that announces exactly what it is. It's like reading the nameplate right on an office door.
And just look at the intel we get from that one single line. We know the protocol is SSH, version 2. We know the software is OpenSSH. And, this is the jackpot, we know the exact version, 9.1p1. We even get a huge clue that the OS is Ubuntu. For an attacker, this is a gold mine. They can now go look up every known vulnerability for that specific version of OpenSSH.
Okay, but what if the door is unmarked? What if the admin was smart and turned off that banner? Are we out of luck? Not even close. A smart scanner can still figure out the operating system just by analyzing the tiny little quirks and how it talks on the network. This is called OS fingerprinting.
See, it turns out every operating system has its own unique network personality. Nmap sends a bunch of really clever probes and just watches how the target responds. It looks at things like the default time to live. Linux usually starts at 64, Windows at 128. It checks the TCP window size, the specific order of options. All these tiny little details combine to create a unique digital fingerprint that Nmap can match against its huge database to say, aha, that's almost certainly a Windows Server 2019 machine. It's incredible.
Now this is the point where we have to hit pause and talk about the real world. We've been having fun with this heist analogy, but these techniques are used every single day by security pros. And that means there are some very, very important rules to the game.
And I know exactly what you're thinking. Running these kinds of scans against some random company? Yeah, that sounds pretty illegal, doesn't it? And you would be 100% right. Probing a network you don't have permission for is absolutely against the law pretty much everywhere.
This is why professional ethical hacking is always done with explicit written permission. Before a single packet is sent, a formal document called the Rules of Engagement, or ROE, is signed. You can think of this as your legal get-out-of-jail-free card. It spells out exactly what you're allowed to test, when, and how. Without one of these, you're not a security tester, you're just a criminal.
And even with permission, testers often need to be as stealthy as a real attacker to properly test the company's defenses. They'll use evasion techniques like scanning super slowly to slide under the radar, or fragmenting packets to confuse firewalls, or even using decoys to make the scan look like it's coming from everywhere at once. It's all about making the test as realistic as possible.
And that really brings us to the most important takeaway of all this. We've been looking at these tools from an attacker's point of view, but their real power? It's for defense. In today's world, the biggest risk isn't that attackers are out there using Nmap and mass scan to find your open doors. The biggest risk is that you aren't. Knowing your own footprint, knowing which doors you've left open, that's not just the first step to security, it's the most critical one.